Let's look at this problem. It says how many molecules of carbon dioxide are found in 2.50 moles of carbon dioxide. This one doesn't have anything to do with mass. We're not asked about mass at any point in time or given any mass. So we're not going to use molar mass. Instead, we're going to use the relationship between molecules and moles. Remember that molecules is one of our three representative particles. We have molecules, atoms, and formula units. In this case, we're using molecules because carbon dioxide is a covalent compound. You're not going to need to know when to use molecules versus atoms versus formula units because it's going to be given to you in the problem in some way. It's either going to ask you for molecules or give you molecules to start with. So don't worry about remembering which term goes with which kind of compound. It'll be given for you. Just realize that when you see any of those three, you're talking about representative particles. And the relationship between representative particles and moles is 1 mole equals 6.02 times 10 to the 23rd molecules. And we'll save carbon dioxide. We'll stick that in over here too. So we have a conversion factor, and now we're just going to do dimensional analysis. We have 2.50 moles of CO2. Because we're trying to get rid of moles, we have to put 1 mole on the bottom, which means we put Avogadro's number on top. Molecules. Be careful when you're writing molecules. Don't abbreviate it as MOL or MOLE, because that means mole. So you've got to go at least to the C if you're trying to abbreviate it in some way. Moles of carbon dioxide cancel out. And we do 2.5 times 6.02 times 10 to the 23rd. And you should get 1.505 times 10 to the 24th molecules of CO2. Now I know some of you are not super confident about using this scientific notation, but it is much easier if you just put it into your calculator. Because if you just multiply the 2.5 times the 6.02, what you'll get is 15.05, and then you add on the times 10 to the 23rd, and then you have to fix it and make it be proper scientific notation. It's just much easier if you just put it in your calculator, using the EE button usually. If you're not sure how to do that, send me a message or go back and read the notes on the page about scientific notation in the Math and Measurements chapter. I go over how to put it into your calculator. It will just make your life easier. One word of warning is to always put your scientific notation in parentheses. Otherwise, you can get some incorrect numbers when you're using it for division. Let's talk about significant figures. This number has 3, and this number has 3, so we're going to round our answer to have 3. So we will have 1.51 times 10 to the 24th molecules of carbon dioxide. Even if you don't leave your compound on while you're doing the math, please make sure you add that CO2 on when you're done. In this case, we're asked how many moles of O2, which we would just say is oxygen, are represented by 7.45 times 10 to the 24th molecules of oxygen. So we know that 1 mole of oxygen equals 6.02 times 10 to the 23rd molecules. We know to use molecules because that's what is used in the problem. So now we're just going to do dimensional analysis using the conversion factor we just wrote. We start by writing down what we know. 7.45 times 10 to the 24th molecules of O2. If we're trying to get rid of molecules, then molecules has to go on the bottom. So we put 6.02 times 10 to the 23rd molecules of O2. And we put 1 mole on top. You can see that molecules cancel out. And we're going to put into our calculator this number. Make sure that you put this value in parentheses. Otherwise, what you're going to do is 7.45 times 10 to the 24th, and you're going to divide it by 6.02. But then you're going to multiply everything by 10 to the 23rd. We have to make sure we're dividing by that. So use those parentheses. Some calculators do it correctly without them, but not all of them. So be careful about it. And you should get 12.3754 moles. Let's look at significant figures. We have 3 and 3, so we need to round our answer to have 3. So 12.4 moles of O2. One comment I want to make is if you're solving for moles, the number should be without scientific notation. It should be, somewhere between 100 and a hundredth. So it should be a reasonable number. If you're solving for any of the representative particles, it should be in scientific notation. It should be a very large number. It should be a very large number because we can't do anything with 3 or 4 or 5 or even 100 molecules. We have to have a very large number of molecules in order to have a significant amount of anything. So that's a good way to check if the math is going right for you and if you're doing it right. If you get 12 times 10 to the 23rd moles, you know that that's almost certainly incorrect. And if you get 10 molecules, you also know that that's incorrect. So go back and check your math and make sure you're setting up your problem correctly.